Download this code from codegive.com, link in the description below. OK, let's dive into Dataweave 2.0 interview questions, specifically focusing on more advanced scenarios and concepts. This tutorial builds upon the foundation laid in previous parts, which, if you haven't reviewed, might be helpful to understand the basics. This part will focus on modularization, error handling, and advanced transformations. Dataweave 2.0, Advanced Interview Questions, Part 4. Key areas covered. 1. Modularization with Dataweave *. Creating and using modules, libraries. Sharing reusable transformations. Benefits of modular design. 2. Advanced error handling. Try-catch blocks within Dataweave. Error propagation and handling specific error types. Custom error messages. 3. Complex transformations and data structures. Working with recursive structures, example nested hierarchies. Advanced array manipulation, example grouping, windowing. Using group by with custom criteria. Dataweave transformations to aggregate data from multiple sources. 1. Modularization with Dataweave, creating and using modules. Concept. Dataweave allows you to create reusable code components by defining modules. Modules encapsulate functions, variables, and even entire data transformations. This promotes code organization, reusability, and maintainability, especially in larger Dataweave projects. Example. Let's create a module to handle common date formatting tasks. File, modules/dateutils.dwl. Explanation. %DW 2.0, specifies the Dataweave version. Output application/JSON, defines the output format of the module. This is crucial. The module must produce a valid Dataweave structure that can be referenced and used in other transformations. In this case, we're outputting JSON, containing the functions as key value pairs. This is a standard way to structure a module's exported functionality. Doc comments to explain the module and its functions. Best practice. Var format date equals, defines a function that takes a date string and a desired format string as input. It attempts to parse the date, and then formats it. Error handling, try-catch, gracefully handles invalid date formats. Var days between equals, another function to calculate the number of days between two dates, including error handling. This is the output directive. It specifies what the module will export. Here, we're creating a JSON object containing the format date and days between functions. This is how we make these functions available for use in other Dataweave scripts. The key of the JSON object represents the reference name of the function within the module. Using the module in another Dataweave transformation. File, main.dwl. Explanation. Import from modules dateutils, this line is critical. It imports all the elements, in this case, the JSON object with our functions, exported from the dateutils.dwl module. The module's prefix tells Dataweave to look for the module in the modules directory. You can adjust the directory path if you've organized your modules differently. dateutils.formatDate, now we can use the formatDate function from our imported module by referencing it like this. Dateutils is the file name, without the .dwl, and the function name is from the JSON object output of the dateutils file. Asterisk date utils. Days between. Similarly, we use the days between function. Key points about modularization. Asterisk naming conventions. Use clear and descriptive names for your modules and functions. Output structure. The output of a module must be a valid Dataweave structure, often a JSON or XML object, that contains the functions, variables, or transformations you want to export. Directory structure. Organize your modules in a logical directory structure, example modules /lib/. This makes it easier to manage your code. Namespaces. Consider using more specific module references, example import date utils from modules date utils and then date utils.format date, to avoid naming conflicts, especially in larger projects. Interview questions. Modularization. Explain the benefits of using modules in Dataweave. Reusability, maintainability, code organization. How do you import a module in Dataweave? Using the import statement. What is the required output structure of a Dataweave module? A Dataweave structure, often JSON or XML, containing the elements you want to export. How do you handle naming conflicts when importing multiple modules? Use specific imports or aliases. Describe a scenario where modularization would be particularly useful in a Dataweave transformation. Large transformations with shared logic, complex data transformations. 2. Advanced error handling. Concept. Dataweave 2.0 provides robust error handling capabilities using try-catch blocks. This allows you to gracefully handle potential errors during data transformations, prevent the flow from breaking, and provide meaningful error messages. Example. Explanation. Try, the code within the try block is monitored for errors. Catch, error, number format exception. If an error of type number format exception occurs within the try block, the code in the catch block is executed. The error variable contains information about the error, example error.description, error.cause. Crucially, you can specify the type of error you want to catch, example number format exception, illegal argument exception, JSON parsing exception. This allows you to handle different error types differently. Error message, invalid input. Error.description, this shows how to access the error message using error.description and include it in a custom error message. It's good practice to provide context in your error messages. Otherwise. If no error occurred, the code inside this block will execute. This is useful to return the converted number and a successful message. Key points about error handling. Specific error types. Catch specific error types to handle them appropriately. This is better than catching all exceptions generically. Error information. Use error.description, error.cause, and other error properties to provide detailed error messages. Custom error messages. Provide clear and informative error messages to help users understand the problem and how to fix it. Error propagation. Decide whether to handle the error locally or propagate it up the call stack. Sometimes, it's better to let the calling transformation handle the error. Otherwise block. This block allows you to have some code execution after the try block if there were no errors. Interview questions, error handling. How do you handle errors in Dataweave 2.0? Using try-catch blocks. How can you catch a specific type of error in Dataweave? By specifying the error type in the catch block, catch, error, my exception. Asterisk how do you access the error message in a catch block? Error.description, error.cause. Asterisk what are the benefits of handling errors in Dataweave? Prevent flow failures, provide meaningful error messages, improve application robustness. Asterisk describe a scenario where you would choose to propagate an error instead of handling it locally. When the calling transformation has more context or responsibility for handling the error. Asterisk what does otherwise mean in error handling? It allows executing some code when there is no error caught in try block. 3. Complex transformations and data structures. A. Working with recursive structures. Concept asterisk. Dataweave can handle recursive data structures, such as nested JSON objects or XML documents with repeating elements. The key is to define functions that can call themselves to process each level of the recursion. Example asterisk. Let's say you have a hierarchical category structure like this. We want to flatten this structure into a list of all categories with their full path, example electronics, computers, laptops. Explanation asterisk. Asterisk fun flatten categories, path equals, defines a recursive function. Categories is the list of categories to process, and path is the current path, initially empty. Asterisk categories flat map, category dash, iterates through each category. Flat map is used to flatten the results, otherwise, we'd end up with nested arrays. Asterisk, path plus plus category dot name, plus plus, this is the base case. It appends the current category's name to the current path. Asterisk, if, category dot subcategories, flatten categories, category dot subcategories, path plus plus category dot name plus plus, else, this is the recursive call. If the category has subcategories, it calls flatten categories again with the subcategories and the updated path. The operator is the optional chaining operator, which prevents errors if category.subcategories is null or undefined. If no subcategories are available, an empty array is returned. B. Advanced array manipulation, grouping, windowing. Grouping with custom criteria asterisk. You can use group by to group array elements based on a custom function or criteria. This will group the orders by customer ID, resulting in a structure like this. See Dataweave transformations to aggregate data from multiple sources. Concept asterisk. Dataweave is often used to combine and transform data from multiple sources, example databases, APIs, files. This involves reading data from different sources and then joining and aggregating it based on common keys or criteria. Example asterisk. Let's say you have two sources. Asterisk customers.json asterisk contains customer information. Asterisk orders.json asterisk contains order information, as in the previous example. We want to create a JSON structure that includes customer information along with their orders and the total amount spent. Explanation asterisk. Asterisk customers map, customer dash, iterates through each customer. Asterisk orders filter, order dash order dot customer ID equals customer dot customer ID, filters the orders array to get only the orders for the current customer. Asterisk total amount, reduce, $$ plus $, calculates the total amount spent by the customer by mapping the amounts of the filtered orders and then using reduce to sum them up. Current value, $, accumulator value. Asterisk we are reading customer and order information from files using the read function, but for simplicity, we are declaring the arrays directly. Output asterisk. Interview questions, complex transformations. Asterisk, how do you handle recursive data structures in Dataweave? Using recursive functions. Asterisk, what is the purpose of the flat map function in Dataweave? To flatten nested arrays. Asterisk, how can you group array elements based on a custom criteria in Dataweave? Using group by. Asterisk, describe how you would aggregate data from multiple sources using Dataweave. Read data from each source, join or filter based on common keys, and then aggregate the data using map and reduce. Asterisk, how do you prevent errors when accessing optional fields in Dataweave? Use the optional chaining operator, or if conditions. Important considerations and best practices. Asterisk. Asterisk, performance. Asterisk, be mindful of performance, especially when dealing with large data sets. Avoid unnecessary iterations or complex operations. Asterisk, clarity. Asterisk, write code that is easy to understand and maintain. Use meaningful variable names and comments. Asterisk, error handling. Asterisk, implement robust error handling to prevent flow failures and provide informative error messages. Asterisk, testing. Asterisk, thoroughly test your Dataweave transformations to ensure they produce the correct results. This concludes part 4 of the Dataweave 2.0 interview question tutorial. Practice these concepts and examples to gain a deeper understanding of Dataweave's capabilities. Remember to tailor your answers to the specific context of the interview question and demonstrate your problem-solving skills. Good luck.